Hello, everyone, and thank you for joining us here for this first edition of How to Build a BHO Extractor. So my name is Joe Goodman. I am the Sales Engineering Director here at Luna Technologies. Jane Boyer, our social media manager, AKA Propane Jane, is joining us as well. Uh,
Right.
we're both going to be helping to answer the chat-in questions that come in during the tour. So say hi, Jane.
Hi.
So today's webinar is really going to be a sneak peek inside the Luna shop with Jack Nato, company president, behind the camera narrating, as well as Ray Penrod, our mechanical technician, walking through 4 various stages of the IO build. You'll get at the end of the tour a look at one of our Canadian units as well. So keep note of questions that you have, chat them in, and we'll get them answered at the end. So, um, the question portion of the tour should be about 20 minutes, and we'll get started shortly after that. So Jane is going to be posting links to the chat-in area for our Instagram and Facebook, as well as our website. I'll post my contact info as well, and also a landing page that's got some great informational videos on it during the tour. And a live recording will also be made available for everybody on here as well. So let's get rolling. I'll pass it over to Ray and Jack in the shop.
Thanks, Jill.
Thanks, Jill. This is Jack with Luna Technologies. I'm down here in the shop, and I'm here with Ray, and we're going to give you a walk through the equipment. Hi, I'm Ray. We've basically got 3 stages of the build represented here. This is the first stage. I've got the distillation column reactor already installed. The frame generally comes to us a couple days before the vessels arrive, so we can kind of time things out pretty well. Second,
generally it's going to be installing the valves, installing all the tubing, the condenser, the molecular sieves, the pneumatic lines for the valves. We'll start doing sensors and gauges over here as well. And then this is a 99% complete machine right here. The build is 100% finished. We've got all the gauges, all the sensors, all the cables installed on here. We've got the vacuum line. We've got it's ready to start the pressure testing program right now. We've got the pump installed. We've got the control panel connected to the IO extractor itself with pneumatic lines for the functional testing and operational testing, and the pressure testing. So yeah, we start there. After about a week, we're here. After about 2 weeks, we're here.
All right, let's go back to the beginning and look at some details.
Yeah, come on over here. These vessels come to us from a fabricator in Illinois. Like I said a minute ago, we generally try to space these out to where they arrive a couple days after the frame does. The frame is made just about 45 minutes south of Portland, all 100% stainless steel. This is an example of what designed, fabricated, and made in the United States might look like. The skid itself is separatable, so you can actually break it in half to slide it through a man door to get into an already established C1D1 room. There are 4 bolts that are removed from the bottom of the frame, and then the back half separates from the front half. You'll have your solvent tanks installed here, and then the process vessels installed up here. Yeah, very easy thing to do in an existing room or one that you'll establish with us. So once the frame is all kind of straightened up and I start putting valves on there, I'll move it over here. If you want to come to the back side, you can see we've got blue cable tray wire looming set up. I've got pneumatic lines running through there right now. I don't have any electronic cables going through here right now because I don't have that stuff installed yet. But yeah, the pneumatic lines and all wiring and cables will go through here to keep a very nice, tidy appearance so you can access things a little bit easier from a support and operational standpoint. The condenser is installed. This is a tube and shell heat exchanger. This is for recovered vapor. The molecular sieves up here are also for the recovered vapor. These will pull any moisture that is introduced during the process cycle. These will pull the moisture out of that recovered vapor so it's not reintroduced into the solvent tanks to be frozen. So over here I will be installing all of the process lines, the 1/2 inch, 3/4, and 1 inch lines. Once those lines are installed in a manner that I'm satisfied with, I'll put the solvent tanks and then continue with the installation from that point.
Can you show us some of the 1/2 inch and 3/4 and where the 1 inch lines are?
Yeah, 1/2 inch lines are generally all going to be solvent or solution. They're going to be for the process primarily. There's much higher burst strength for that, and since they are running at a higher pressure, we want to minimize that chance. So yeah, we've got 1/2 inch lines for process. 3/4 inch lines are not installed right now. We'll see those on the next stage. The 3/4 inch lines are for the hot water system for the distillation column. And then the 1 inch lines, I do have a few of those installed. These are cooling lines for the 2 solvent tanks and the reactor vessel. And then, yeah, again, the 1/2 inch lines are primarily process lines. You can actually take a look here. It's a very easy thing to fit in. These are compression fittings, Swagelok, Hamlet. There's a few other brands that use a very similar system, but a very secure way to prevent leaks in process lines. So we're a little kinked here, but we've got a nut. Come on, there we go. A nut and 2 ferrules. These ferrules do have to be oriented correctly in order to provide the best fit with no leakage.
All right, can you show us how to install those?
Yeah, sure. Let's come over here first. We need to swage that nut and ferrules onto the end of this tubing. So you saw how I had those oriented, tapered, and in the correct order. We will insert the tubing all the way until it will not go in any further. That's what we refer to as full penetration. Spin the nut on. It should go on very, very easily. If it doesn't, then something is wrong. Stop what you're doing. Get it all the way to where it stops. You're not trying to finger tighten it here. You just want to get it to where it stops. Mark one point on the nut with a handy marker. And then take your wrench and turn it 1 1/4 turns from that mark. So I generally will start with the 1/4 turn first, right about there, and then 1 turn past that. And we have a swaged fitting that will hold lots of pressure.
All right.
Easy to do, easy to repeat, and one of the best things about this is that these can be uninstalled and reinstalled with no damage. You can uninstall these lines for any sort of service that you need, and to reinstall, all you have to do is spin the nut on there and give it just a little bit of a turn with a wrench, and it's secure.
All right, so we put it back on the skid?
Yeah, come on back over here. Ideally, like I said, all this stuff should spin on very easily. So we'll just insert that, spin it on with the nut here. Everything's going just fine. And then the other end, same way. Just fingers.
Easy.
Easy.
And then you'll come back later.
Yeah, I'll hit it with a
too.
wrench just to snug it up a little bit more, and it's ready to go.
Okay. Where's the next stage?
Back over here to the testing bay. We have, again, cables, sensors, gauges, all installed on this machine. solvent pump is installed. We have all of the process lines, the hot water system lines, the cooling lines, everything is installed. This machine again is like about a 99% ready to go. We can take a look inside the reactor column here. You'll be able to see at the bottom there's a screened filter down there that will separate your any biomass from the solution so it doesn't wind up in the distillation column after the drain cycle. You can see a float sensor here. This is a redundant float sensor for the high level on the reactor. We've got two sensors also in the reactor that are optical, one at the top and one at the bottom. The reason we have the redundant sensor in the top is to prevent overfilling of a hydrocarbon solvent. Obviously that would be a bad circumstance. So if the optical sensor for some reason fails or does not read correctly, the float sensor will back that up. So we won't have to worry about overfilling butane or propane.
Can you show us those optical sensors?
Yeah. You can see the one down here at the bottom. This will detect any sort of liquid, and one at the top here.
All right.
Those are explosion proof. That is an important thing to hit on. Everything on the IO extractor is either explosion proof or intrinsically safe. The reason for that is if we're dealing with a hydrocarbon, petroleum gas, that is a highly flammable substance, any spark will cause ignition. Obviously that would create a very bad situation. So intrinsically safe means that there is not enough current in any of the electrical connections to cause a spark. And explosion proof is just that. Like if a spark does get created, it is contained. So there's no chance for that spark to leave that container. An example of that would be this little electrical connection box here on the solvent pump. This is explosion proof. This is intrinsically safe. A little difference there.
All right, can you keep walking us through the sensors?
Yeah, we've got the three process vessels, which would be the two solvent tanks and the reactor. They're all, they have sensors for pressure, level, and temperature. Pressure sensors are General Electric pressure transducers, very reliable sensors. All four vessels have one of these. All four vessels have an Omega thermocouple probe for temperature. I can show you a short one of those. Where is it? Just a very simple thermocouple. This will read temperature, and this sends the signal to the control panel.
All right.
And there, like I said, there are four of these on the machine. This is the shortest one. This is strictly for the reactor. The reason this is only a couple inches long is because it only has to go in there deep enough to get through the jacket, and we do not want it interfering with the biomass basket as it gets inserted into the column. Level sensors on the two solvent tanks. These are 4 float level sensors. Where did it go? Are you moving it? Oh, there it is. We got 4 level floats in here. As the solvent is filled in the solvent tank, these will float individually. This is 25% full, 50%, 75%, and 100%. So a very easy, rudimentary, and reliable way to detect level on the 2 solvent tanks. Also, you saw the float sensor on the top of the reactor column as well. Let's see.
So about how long does it take you to install the sensors and then after that to wire them all up?
That usually, I mean, the sensors themselves are easy to install, generally speaking. Let's see, 11 sensors. 13 sensors. Yeah, 13 sensors on the whole machine. Those, I mean, I could probably get all of those installed in, 2 or 3 hours. Cabling takes a little bit longer because, like I said, we do want to make sure everything is neat and tidy. If I pull this off, you'll see a cluster of cables and pneumatic lines in there that is just generally unsightly. We want to keep that stuff kind of hidden away, and again, for ease of access for service and operation. So yeah, there's a lot of wiring, cables, and pneumatic lines inside those cable trays.
Can you show us where the all the cables are running?
Yeah, all the cables run to the J box. Again, this is intrinsically safe. I don't have everything connected. Actually, yeah, I'm missing one cable here still. But yeah, this is the main input-output cable here. We've got cables for these are level sensor, these are temperature sensor, or these are pressure sensor, these are temperature sensor cables. So everything is run through these trays. I try to keep everything kind of neat and tidy and as possible down here with lines running in different directions to different places. It can be a little tricky, but I try to keep things kind of tidy. And then this harness here is strictly for pressure testing. It just runs from the pneumatic bulkhead on the BHO Extractor to the pneumatic manifold on the control panel. And this actually sends little bursts of air through these lines to open or close the valves as necessary. The reason we do pneumatically controlled valves goes back to that C1D1 and hydrocarbon gas. We don't want electrical current to cause a spark. Pneumatics can't cause a spark. So we go to pneumatically actuated valves for that reason. That's what this manifold takes care of here. We've got connections here for your two chillers, your network router. This actually gives you access for remote viewing, remote processing even, and also us capability to do some remote troubleshooting and repair and service for you. So all of that is taken care of there. We've got a USB port here. This allows you to download all your logs, to do any software updates, just various things can be done there. And then cables for water pump starter, your solvent pump starter, reactor level sensor here, stack light that will give you, basic status updates of what stage of the process you're in. And that's pretty much it. The control panel itself gives you a lot of flexibility. It's a very nice designed process flow diagram here. You can see animations, and the green valves are actuated on. The gray valves are not. You have the option to actually control these valves individually, manually, if you have the know-how and are confident in the skills that you possess to run a machine manually, such as this. The HMI also gives you current status updates on what stage of the current process you're in, as well as past stages and how long they were. And then, you've got recipe control here as well. It's a very, very flexible, it's a one-of-a-kind kind of automation and HMI system. There's really nobody else in the industry that is offering the level of automation that Luna Technologies offers on the BHO Extractor.
So which screen are you using here for all your testing?
For testing, I will most likely be going over to the process control, the manual control screen. Here you can turn any individual valve to automatic or manual. You can operate it manually here, turn it on, turn it off. There's about 100 psi of air pressure that goes into this manifold to operate the valves. That's just run from a general air compressor that you'll have installed on site. It doesn't take much, just a $120 air compressor from Harbor Freight would get the job done. But that is enough to operate all of the valves for an entire extractor and for an entire day.
So this skid is complete and it's going through the testing process.
Yeah.
Can you give us the bullet points, the main points of what we do in testing?
Yeah, there's functional testing and pressure testing. Generally, we start with pressure testing. There are 4 individual tests for pressure. I've got one actually kind of staged and ready to go here. The main pressure test is for all of the 1/2-inch lines, the process lines, that will be passing solvent or solution through them. And those are tested up to 285 pounds. That is compliant with ASME code. You'll never see that pressure when you're running the extractor. However, we want to make sure that we are rated up to that pressure. So yeah, we test process lines to 100 or 285 pounds of pressure over a half hour. All of these tests are over a half hour. The jacket lines for the reactor and the 2 solvent tanks, we test to 45 pounds of pressure. Same with the distillation column jacket, the hot water jacket, we test that to 45 pounds of pressure as well. And then the condenser here, this heat exchanger, since it is such a short circuit, this is the input, this is the output, just goes through here. We test that one to 80 or 75 pounds of pressure. If there is any pressure loss over 30 minutes for any of those tests, the test fails, we find the leak, fix the leak, and test it again.
All right. So we saw most of the stages from getting the frame, receiving the frame in the shop, putting vessels on, putting valves on, wiring all the sensors, and then functional testing. Where does it go once it's ready to ship out?
Once it's ready to ship out, we'll put it on a pallet, crate up the walls, and we'll stage it up here. You can see we've got a Canadian spec machine ready to be shipped. Essentially, it's still missing a little bit of insulation, but it's basically ready to go. This is a Canadian machine ready to go. You'll see a lot of visual difference between this machine and the machines we've been looking at so far. They are the same process. The IO extractor is the IO extractor. So this is the same process. The only visual difference is this is the heat exchanger. You can see it's quite a bit larger than the one we were looking at over there. The only visual and mechanical differences you'll see on this machine to the US machine are due to differences in regulations between Canada and the United States. The process is identical. The sensors needed to be changed, the heat exchanger needed to be changed only to meet Canadian registration requirements. This machine would operate in the United States just as well as a US machine would operate in the United States.
All right. Hey, we walked past a few of the carts where you kit all the parts. Could you show us those?
Yeah, kind of the first start of the build process, actually. Once we get the frame in and we get an order for an IO extractor to be constructed, I'll pull all the parts. This is the entire bill of materials for an IO extractor, as far as fittings, valves. We've got a quick connect for your solvent fill. We've got clamp blocks for the heat exchanger and the molecular sieves. This is our reactor float level sensor. Got the safety relief valve. This is the machine that goes onto here.
All right.
Yeah.
All right, great.
So
Thanks, Ray.
that's about it. Yeah, glad to help.
We'll send it back to you, Joe, and then we'll come back for questions.
All right.
Awesome. Well, thank you, everybody. That was great, and thank you for all of the chat-in comments. Got a couple like so epic, and obviously, this machine has just some amazing capabilities, and thank you all for being here with us. We'll let Jack and Ray get set up in the conference room. We're going to be taking some live questions from everybody here. We'll take about 20 minutes for questions. Both Jane and I will ask the questions directly that you guys chatted in throughout the event. And then if you have a specific question for Ray or Jack, just specify, and we'll get those answered for you. So we'll go from there. And Jack, are you up and running?
Yeah, we're here. You're up.
Awesome. Awesome. Yeah, let me just move you guys over here. And Jane, are you up as well?
I am. Do you want
Okay,
me?
awesome. Yeah, you can turn it on. I'm in the corner. It's up to you.
All right.
All right, awesome. So, like I said, we've got a ton of questions that have come in. Thank you so much for the questions. I'm just going to kick it off here with Jason. He just had a question. I think it's a general question. Maybe you guys both can answer, but wants to know what your favorite part of the machine is and why.
Oh yeah, sounds like something I can answer. You know, I'm a big fan of just like quality fabrication, quality machining, you know, like just well constructed pieces of equipment. And that Exergy heat exchanger that we use on the US skid, just looking and feeling the construction of that. There's over 200, you know, small diameter, 1/8 inch diameter tubes in that larger tube, and it's just a really neat piece of equipment to feel the quality of and see the intricacy in the design.
Yeah, I actually saw someone had a question about that, why the Canadian heat exchangers seem so much bigger. That's part of the reason. Exergy is one of the only companies that'll put 200 something 1/8 inch tubes into a tube and shell heat exchanger. Unfortunately, they're a great supplier, but they didn't have Canadian registration for that unit, and that's why we had to go with a different supplier. So to get the same amount of heat transfer area, which is what we need for condensing the vapor, we had to go to a bigger unit. So that's the difference. They're effectively the same. They have the same effect on the process. One's just bigger.
Cool.
Okay, so one of the questions here is, are your manufacturing partners ASME certified, ULC certified, and does the equipment have compliance for Canadian operations with CRN numbers? So it kind of rolls into that also.
Yeah, so we have, I guess I'll start from the top. All our vendors, all our pressure vessel vendors are ASME certified. All our pressure vessels are stamped with ASME U marking. And our control panel is UL listed under 508A and 698. And the last registration, CRN. Yeah, so we have CRN in every province. We have a unique CRN for our skid. So like our extractor has its own CRN number. That's pretty unique and makes your application and certification process in Canada a lot easier. And we have that in, I believe the last province we applied for was Quebec, and we just submitted that. Everything else is already established and granted.
Awesome. Thanks, guys. So I've got a question here from Steve. This is about the shelf that's placed. He's wondering if it's welded in place or if it can be moved on the unit for bigger dishes.
Yeah, that drip tray, there's 4 different levels that you can place that. Well, technically there's probably 5 different levels that you can place that at.
Yeah, and just,
you know, so if you have a bucket that you need to dump a bunch of material into, or, you know, a flat piece of parchment paper that you're gonna dispense some shatter onto, you can adjust the level of that drip tray pretty easily.
and that's the tray that's below the distillation column. So when you're finished with the
yeah, below the spigot.
Yeah, exactly.
Okay, so the same gentleman that asked a question about the Canadian certifications also asked, the gaskets and seals on non-metal fabrication, what's the lowest temperature you're rated to operate with? And does propane also work with this configuration?
Yeah, so we're rated for -65 Fahrenheit. That's all components, including seals and gaskets. Some of our components are rated to a lot lower, but our limiting components are in -65. Everything is fully certified for propane, for full propane or any blend of butane and propane. So we have probably, I'd say 5 or 6 customers who are running pure propane right now. And yeah, all of our certifications translate into Canada through CRN and CUL and CSA.
Awesome. So got a question here from Laura. This is directly for Ray. Ray, how long does it actually take to complete the build of one machine, start to finish?
If I've got everything in stock, the frame, all the components, all the valves and fittings, all the tube sets, you know, if all the vessels, if everything is in stock, I can get through a build in, you know, 2 to 3 weeks. It'll be done from a bare frame to ready to ship.
Awesome.
Yeah, and typically that's just Ray taking it through the entire build process, or at least one assembly tech. We like to do that. So once you start getting a lot of different hands on one machine, there's just a lot more room for error, a lot more room for things to be missed. So yeah, one tech takes it through from start to finish.
What is the footprint of the machine and the Canadian version also?
The footprint of the US, the extraction skid is it's just under 5 feet by 5 feet. And the Canadian version is just over 5 feet by 5 feet. We made it a little bit bigger for a few reasons. One of them is that bigger heat exchanger. So it's about 5 foot square in both cases. We have really complete install drawings that we can send out if you'd like to see them. It'll include all the footprints of our auxiliary equipment too.
Awesome. So I got a general question here from Aaron asking, why are there 2 solvent tanks?
That's so you can, I mean, to answer that simply first, that is just to allow you to do 2 processes at the same time. With 2 solvent tanks, the software in the control panel will actually determine which solvent tank to pull solvent for one cycle, for one process. You know, that software decides on which tank based on a combination of temperature levels, fluid levels, solvent levels in the tank itself, and pressure levels inside each individual tank. And the software makes that decision, fills from one tank into the reactor, soaks that reactor, moves the solution from the reactor to the distillation column, and at that point you can actually start a second process. You can open up the reactor, unload the first basket of biomass, load a second basket in, and then close the reactor, start a second process, and the software determines again which tank to fill from based on level, temperature, and pressure. Without 2 solvent tanks, you are stuck doing 1 process an hour. With 2 solvent tanks, you can do 2.
Huge.
Double your throughput.
That brings me into Eric asking a question. What's the recommended method for emptying the material column after extraction?
That's a pretty simple one. Yeah, once the solution is moved from the reactor to the distillation column, you'll get an indication on the control panel and a much more visible indication from a lit stack light. That stack light will tell you that you can unload the first reactor. At that point, you can look at the control panel, verify that the reactor is not under pressure. If it is under pressure, and that it's generally just a very, very small amount of pressure or vacuum. If it is still under vacuum and you can't open the reactor, there's a manual ball valve right behind the reactor that you can open up. That will allow atmosphere into the reactor so you can open up the lid. And it's at that point, it's just a matter of reaching down into the reactor, grabbing the filter bag that is containing the biomass, lifting it out, and then putting another one in its place, sealing up the reactor again, and pressing a start button.
Yeah, so the last process after we drain the solution out of the reactor is to recover as much solvent. There's always some solvent stuck in the biomass. Just imagine like when you pull a tea bag out, it's still wet. So we try to recover as much of that solvent as we can through our solvent recovery pump. And that's why the reactor's under vacuum at the end of the run. And then the other thing is what Ray was saying, that your operators are notified with a big stack light. That's just like a big green light that sits outside your extraction booth. It'll blink green as soon as you're ready to start the next run, so they know. And hopefully within the next month, we'll have text message notifications too. So when your tech logs in for their shift, they'll go into they'll be in the notification system, and it'll shoot them a text message when the run's finished and when it's ready to change out.
And somebody asked if you had, if you were able to show the sock or sleeve for loading biomass, and I know you might not have it up there with you.
I will text someone and have them bring it up while we keep going.
So I'll just ask, while we're doing that, I'll ask this question from Jamie. And Jamie was noticing on the Canadian skid, there's huge blue sensors on the back of the solvent tanks. What are those on the Canadian extractor, and what are they used for?
Those are the level sensors for the Canadian machine. Due to, as referred to earlier, the Canadian registration requirements are a bit different than the United States. One of those things was that they couldn't have any sensors actually touching solvent or liquid or solution. So those larger blue sensors, those are guided wave radar sensors instead of the simpler float sensors that are on the American skid. So those actually send a radar signal into the solvent tanks and will determine a level of solvent from 0% to 100% in single percentage increments, whereas with the floats, we're left with 25% increments. So, I mean, the short answer to that is that those sensors are replacements for the float sensors that are required for Canadian registration.
Gotcha.
Oh, this is a good one. Brent asked, is the manual operation controlled by a password? I wanted to be able to control and ensure that not everybody can access everything that is on the PLC.
Yeah, so we have, I think we have 5 different permission levels on our control system. Any of your operators can sit in any one of those. The highest one is for your admins. So yeah, the lowest level, or I think the lowest 2 levels, are fully locked out of manual control. And we can always tweak those for you a little bit too. So every single button on the control system, we can decide who has access to that function. So
thank you.
With a filter bag.
Thanks, Adam.
Awesome.
Yeah, so here's our 25 micron filter sock. Load biomass in here in a few different ways. We've got an automated pneumatic packer. I should say semi-automated, but it'll take your biomass, pack it into 5 to 10 pound bricks that are about this big. You'll take 2 or 3 of those bricks, pop them in the filter bag. We've got a nice little clip that just seals the top up, and then you can see how big the bag is. This drops straight into the reactor, and then at the end of the run, you pull it out, dump out your biomass, and we reuse the bags depending on who the customer is. Some are using them, some are not reusing any bags, but most are using them between 5 and I think probably up to 20 uses before they waste them.
I put them in the extractor and clean them.
Right.
Yeah, exactly. Yeah.
Like to do.
All right. So I got a question from Ryan, and this is for Ray. So ultimately asking, how are the valves being operated from the control panel, I assume?
Yeah, it's all pneumatic. All of the valves, the red blocks that you see mounted on the skid, those are actually pneumatic actuators. The valve is connected to that. So the control panel is fed about 100 pounds of air into a manifold that then distributes the air based on what process is called for. The software determines where to send a tiny little burst of air, and when that burst of air is sent, it operates the valve. It opens it if it's a process valve, or closes it if it's one of the cooling valves.
Okay, and the follow-up question to that is, what happens if you lose air pressure?
Everything shuts off. It defaults to off. If there's no air pressure, there's no way the valves can actuate. So what that means is that any solvent or solution that is active in the system is isolated and remains in place. It doesn't go anywhere else. At that point, you can manually isolate each individual solvent tank. If you do have to, break any lines open, there's no additional solvent being introduced into the lines, so you can troubleshoot the issue and find out where to fix the problem.
Yeah, and one of the purposes of that is if, let's say, you have like a catastrophic failure, just comparing an automated system to a manual system, some sort of catastrophic failure where your building loses power, plus you have a leak on your extractor, our system will isolate that leak on its own. You don't have to have a technician or a safety officer coming into the extraction area, into the hazardous area that's causing the issue, to try to find the leak and then isolate it. So people, in the event of some catastrophic failure, they can evacuate safely and trust that the extractor is going to shut itself down.
Awesome.
Okay. Do you do the pressure tests under different temperature ranges based on operating ranges?
ASME certification doesn't really require that, and we're running at very cold temperatures. We may run into some material brittleness at very cold temperatures. However, our fabricators have met their standards. We test those standards just to back up their own testing, and yeah, we haven't had any issues with vessels failing at all.
So
we follow ASME code for all our pressure tests, so everything's tested according to ASME B313 before it leaves the shop, and that code does not require anything but ambient temperature for our tests, especially because we're in a really narrow temperature range that we operate at. If we're up to a couple thousand degrees, it'd probably be a different scenario, but we're between pretty much 140 degrees Fahrenheit and minus 65.
And I think also me personally operating the equipment, seeing that the chillers keep it in such that the chillers are properly sized for the equipment and keep it in this pressure and temperature range that I think that you actually do a lot doing that 30-minute pressure test, because not all manufacturers do that due diligence. So seeing that the chillers, and that's something that they couldn't see unless they're operating it, that the chillers keep everything in that temperature range on purpose, and it's extremely controlled. So
yeah, I mean, that kind of leads me into this next question here, which would be a good segue. And this is for Jack. Why does the Canadian unit have the lines insulated, but the US unit did not in the video?
Oh yeah, I guess we just caught it at a funny time where that final US unit downstairs is basically completed, but it hasn't been fully pressure tested yet. So as soon as the pressure test is over, we'll insulate it. All our process lines on US and Canadian vessels are professionally insulated and sealed. That's because we operate at, like Jane was saying, such low temperatures. The other thing you might have noticed is that we don't have any of the cloth insulation jackets that you see on a lot of BHO extractors, those like black cloth sleeves that are on the material columns. That's because those are just completely inadequate for our cooling. We've tried those in the past, and at our temperatures we'll get a thick layer of ice around that insulation. And so we only use professional insulation that's integral to the pressure vessels. It's all welded in and I think it's an inch thick rock wool. So yeah, to answer your question, both U.S. and Canadian vessel or Canadian extractors will be insulated, but we wait until after pressure testing.
Thanks, Jack.
Paul asked, can the IO be used for ethanol? And if not, can it be modified to use both types of solvent?
I mean, it could be modified. We don't recommend doing that modification. Mostly because the temperatures that you have to go up to boil ethanol or to recover ethanol are a lot higher. Otherwise, you have to use a lot higher vacuum levels that we can't produce with our pump. So the system's really designed to do, it was originally designed to do fresh frozen material and process that really, really well to make a really high quality product. We've also built out programming to process dry material really well with butane and propane, but there's just a lot of design changes and a lot of things that you have to give up on the quality side for ethanol extraction and LPG extraction if you try to put it into the same unit. So designing for LPG specifically made sure that we could produce really high quality BHO products. And if we designed it to run ethanol also, we'd give up a lot of that.
I tell people, yeah, you can use the columns. That's usually you can take apart all of the equipment and literally just use the steel columns because because the ethanol can eat away at your gaskets and things like that too. And so it can cause a lot of problems to put into that system, Paul.
Yeah. Jane, did you have any other questions? I know we got a couple more on there.
There are, well, let's see here.
I think we can handle maybe one more question and then we are at time. So I'll let you ask one more.
Oh boy. Oh, there's so many.
Please.
There's another, and also all of these, the people that we don't get to, I'll just privately respond to them if it's possible. I'll do that. But this is it's another Canadian question. It says the relief valves, do they have to be vented to the outside? And this is probably someone that's more familiar with CO2, and that's why they're asking. But Brent asked if they have to be vented outside through tubing, or can they vent directly into the C1D1 zone for the Canadian version?
Yeah, so there's a lot of, I don't know, that's a big question in general for BHO extraction. They don't need to be vented outside. Some jurisdictions will require you to do that. We haven't run into one yet. Essentially, our extractor falls under a C1D2 classification. If you really look at it, we're not producing an explosive level or an ignitable level of an ignitable concentration of flammable gases under normal operating conditions. That's the requirement for C1D1. But we put it in a C1D1 booth anyway. In a C1D1 area, if you're relieving solvent vapor into that room, it'll be taken out by the ventilation in the room anyway. So short answer is no, you don't have to plumb those outside. The thorough answer is check with your local jurisdiction and see what they require. We can do either.
And we can,
Yeah.
Awesome. Hey, thank you so much, guys. Appreciate the time. Like I said, we have a number of questions, and Jane mentioned too as well, that just didn't get answered here today. So email them in, chat them in. My email is on there. Send me that directly. I'd be happy to get those answered for you and make sure you get everything you need. Thank you so much for joining us for how to build a BHO extractor. It's been a pleasure to give everyone here a peek under the hood at Lunatech. So stay tuned. We're going to be doing more of these over the next few weeks, sending out messages through email, Instagram, Facebook. So take a look and you'll see those come through. So until next time, from all of us here at the Lunatech team, thank you, stay safe, and happy extracting.
Thanks. Thanks, everyone.
you.
Bye.
Bye, guys.